control shell access. Open the password file by vim.tiny/etc/password. Access will be granted when there is /sh in the end of the user account of the password file. Access will be denied when /sh is replaced by /false. Otherwise, access will be granted. Ban access for all the accounts except root and system user.
Now we need to configure our password file. So type vim.tiny/etc/password. These are the accounts on Ubuntu system here. These, you can see here, these accounts are enabling the asset, that is shell. As long as they have shell, hackers can try to hack into their account. So we should disable these shells so that hacker cannot hack into the system even though they have password of our account. So type I for inserting and replace asset with false. We can do it for bin also, and sys and whatever you like, but do not do it for root and system user because it will disable the shell for them. Once it is done, press escape :WQ for saving and to quit the file.
Disabling user accounts. Easiest way to stop a user from logging in without completely removing or deleting his account is password -l username. This option is available to root only. After locking, if someone tries to log in using this account, the system will return su-username. The account is currently not available.
Now we are securing the shadow file. So type vim.tiny/etc/shadow. In Unix-like operating systems, /etc/shadow is used to increase the security level of passwords by restricting all but highly privileged users access to hash password data. Typically, that data is kept in files owned by and accessible only by the super user. So this is a very important file. If you mess with this, you might not be able to log into your Ubuntu machine. So we should quit this and make its copy. So type C -P -A/etc/shadow etc/shadow backup. It's the backup file. We have to make a backup file for the shadow. We should make a backup file when we are changing any important file before editing the file. Now we should write vim.tiny/etc/shadow again for getting into that file. This exclamation mark is for the lock, that is root is locked here. So open a new terminal. Again do sudo -i to become root. So if we want to change daemon or bin or sys or any other and make them locked, we have to do it here. Just write password -l and name of that account. You can see here it is not logged, but when we escape it and again enter into the file, you can see it is logged. We need to do it for all the accounts in the shadow file, so let's do it for some. Now type password -l and bin and password -l sys, and now go to this. These two are not logged, so escape Q. Again type vim.tiny/etc/shadow, and now you can see here bin, sys, daemon, all three are logged. All the accounts, not for 1 or 2, for securing our shadow file.
Detecting rootkits. A rootkit is a collection of tools that a hacker uses to mask intrusion and obtain administrator level access to a computer or computer network.
Now we have to detect rootkits, that is a malware. Rootkit is a stealthy type of software designed to hide the existence of certain processes or programs, methods of detection, and enable continued privileged access to a computer. So we are doing it with RK Hunter. So type aptitude install check rootkit RK Hunter. Okay, it is not installed, so we have to install it. Why? To accept the solution, and second why? To start the software. RK Hunter is a Unix based tool that scans for rootkits, backdoors, and possible local exploits. So now we have to configure it. Press tab key for this OK. Now go to local only with the arrow keys and then press tab key for OK. We are not changing the mail name, so press OK again. It may take some time. The system is configuring the RK Hunter and check rootkit. Okay. Now type RK Hunter --update. It's like a password definition for RK Hunter. It's checking the RK Hunter data files. Okay, we can say what is updated and what's not updated there. So if you if we have rootkit, so we have to remove it, otherwise we are exposed, otherwise our Ubuntu system is exposed to the hackers. So do rkhunter -c to run a check on your system. Okay, you should see there is warning here. Now it is checking for rootkits. Not found or okay means that our system is okay. That's a good thing. It will take some time. Okay, now we have the system check summary. So there is one suspect file. That means something is wrong in our system, and possible rootkits is 0. That's a good thing. So that means there are no rootkits in our system.